All right, let's get started. Thanks for coming. Welcome to the talk on type inference, friend or foe. We're going to talk about type inference in Java, but not just by Java 10. I'll talk a little bit about where type inference has been in Java even before Java 10, and then lead up to Java 10 and Java 11 and what changes have been made in the language. If you do have a question or a comment, I'd be delighted to hear from you, so don't hesitate. Just draw my attention and start speaking. I'll be happy to hear. So let's talk a little bit about typing, and then we'll continue a little further. Well, when it comes to typing, we know there are static type languages and dynamically typed languages. Static type languages verify type sanity at compile time. Dynamic type languages don't really bother to check types at compile time or code writing time. Some languages don't even use compilers like JavaScript and so on. On the other hand, when it comes to typing, how do you really specify what the type is? Well, I used to believe that in static type languages, we have to say all the type all by ourselves. And this is one of the problems of predominantly programming in one language as I used to a few decades ago. And the very first time I came across a different language, I was in a bit of a shock because the static typing was not really the same. And I would say the static typing is actually a spectrum. If you look at a language like Haskell, Haskell is a statically typed language. It's also a functional programming language. I failed learning Haskell 3 times in my life. And the first 2 times I struggled really hard and I had difficulty learning Haskell. And I was not able to put my finger on why I had such a difficulty with it. And then, of course, I kept hearing people tell me how wonderful Haskell is. And I went back with vengeance and I said, I'm going to learn it this time. And what I did the 3rd time was I did not put any type at all. I just started writing code without putting any type. And the first time I wrote the code, I almost felt like Haskell was looking at me with his wise eyes and saying, you kid, you finally understand this stuff. Well, that is the beauty of a language like Haskell is. It is statically typed so well that you don't have to type the type information with your fingers. So when a language is more statically typed, you do less typing. When a language is less statically typed, you do more typing with your fingers. Well, just to quickly look at this, Haskell is a language which is statically typed, but let's just entertain this thought just to get a feel for it. Here I am in the REPL for Haskell GHCI, and I'm going to say let's say P and Q is equal to P plus Q. So I'm just adding 2 numbers, and I call add with 1 and 2, it gives me 3. What if I call add with 1 and hello, for example? Well, in this case, it just gives me a little stare because it's not proper to add a number with a string. Now, notice that it knew somehow that P and Q are supposed to be numbers. How in the world? Well, that is static typing. Well, just to kind of set the tone on this, let's go back one more time. And I'm going to say set plus T. This is a little flag into the Haskell REPL to be a little chatty. Tell me about the type when you're inferring the code or compiling the code. So now I'm going to repeat the code we just wrote, let add, but notice it says that it is a number. So how did Haskell figure this out? Well, through code analysis. Haskell looked at the code and said, I wonder what in the world has a plus symbol attached to it, operator to it, and decides that it's going to be a number. So Haskell can figure out types really nicely. In fact, what you see here is a concept that you can extend further to templates, and it can really infer the type very nicely. Well, some of the languages that have done this really well in the past are languages like Haskell and Scala and Kotlin. These languages were born with static type inference of static typing from the get-go. But then some languages introduced type inference much later in the game. And for that list, C# is a good notable example. C# introduced type inference several years ago with the var keyword, and for crying out loud, even C++ introduced this before Java did with the auto keyword in C++. So Java is, of course, kind of last to the party, but I'm really glad they have joined us eventually. So this is where Java has a beautiful static typing, has type inference baked into it. But Java has had type inference for a very long time. It is just that the difference between static type inference in Java 10 versus earlier is there's only one difference. The type inference in Java 10 made programmers angry for reasons I don't understand. But it's been around for a long time, and we've been quietly using it. Now let's look at a little bit about type inference in earlier versions. Well, Java 5, of course, introduced generics. And before the time of generics, of course, as you know, you had types where everything was treated as a collection of objects. It was not fun. Well, Java 5, of course, introduced generics for us. We were able to provide the angle bracket and put the type information in it, and it would verify if the object we passed to it is a valid type or not, which was really good. Now, this worked really nicely, except when it didn't on occasions. So there are some times when you would have to really give a clue to the type inference because it's not, doesn't have enough context to figure it out. I'll give you a really quick example here without going into too much detail because of lack of time here, but just a little example. Sometimes you have to do this. You may say, some class dot foo, and you may call this function, but occasionally you may have to say my type over here like this. And this is a notation we don't have to use too often, but there are times when you have to do this because the compiler doesn't have enough context to know what the type is. Now, what is important to keep in mind here is type inference is not magic. Type inference literally works with the information that's available in front of it. If that information is not available, it's not going to do anything with it. It's going to fail. So you have to provide enough information for it to use. But moving a little further, Java 7 took that to a whole new level, if you remember. Before the time of Java 7, you had to do something like this. You had to say integer, let's say numbers is equal to new array list of integer. Now, this was sad because you had to do it twice, not just once, and that was a punishment. You had to keep repeating that over and over, and that didn't sound so intelligent. Well, Java finally said, you know what, we don't have to say this over and over. They introduced the Dimond operator. What is nice about the Dimond operator was that it infers what the type is based on the context. So in this case, it's an integer because that's what you have on the left side. That was introduced in Java 7, which is really nice. I love it. But there was one limitation in Java 7. And that limitation was this code I'm going to show you right now will not work in Java 7. So if you had said, for example, add 1, this code would not compile in Java 7. And the reason it will not compile in Java 7 is Java 7 gave us the Dimond operator, but you cannot have anonymous inner classes with Dimond operators. Good news, that restriction was removed in Java 9. So if this code were run in Java 9 or later, that's not a problem at all. Java 7 and Java 8, this code will not compile because you cannot have anonymous inner classes with the Dimond operator like that. Well, given that, of course, let's now slow down a little bit and talk about Java 8 and type inference. Java 8 is the first version of Java in a long time I truly got excited about, thanks to Lambda expressions and functional style of programming. Well, in that regard, if I were to create a collection, let's say integer, we'll call this as, let's call it as numbers is equal to a list of, let's just take a bunch of values right here. Now, what I want to do is to iterate over this collection and print the value. So I'm going to say over here, integer of element E, and I want to output the element E right in there. So when I run this code, what it's going to do is to print those values. Now, when you look at this code, it worked, obviously. But when you look at this code, what are we saying? We are saying that as you iterate over the collection, if you give me an integer, I want to print it. But in your wildest imagination, think about this for a minute. If you put your hands into a collection of numbers and you pull one element out, what in the world possibly the type of collection of integers would be? Dog? No, it is going to be integer. You know it, I know it. Why say the obvious? So in life, I've realized that we should almost never say the obvious. I say almost because I love you to the partner is a good thing to say. It's redundant, but keep saying it. But everything else is no need to really repeat that. So in this case, you can drop that integer because it's so darn obvious. Well, that is type inference. So Java figures out what the type is. Make no mistake, this is not in the runtime, it is at the compile time. Just to illustrate the point, if I do a foo over here, look at the error it gives us. It says method foo variable e of type integer. So the compiler clearly knows e is an integer at compile time, and that is basically what type inference is. And to emphasize, I want to confirm that type inference is all about compiler time, not runtime. So the bytecode generated will have all the type information. It never leaves it to the runtime for this decision. It's decided at the compile time already. So in this case, as you can see, the type inference kicks in and figures out what the type of E is. But as a bonus, of course, in a single parameter, you can even leave out the parenthesis if it is not using the type information, whereas you cannot leave the parenthesis out in this case. That's not a valid syntax. So that is type inference at this point. Now, this is great so far. We can use the type inference, but unfortunately, there are some limitations we have to still work with. One limitation, unfortunately, is that you cannot have annotations with type inference. So this is a limitation in Java 8 that you can use type inference, but only when you don't use annotations. So just to illustrate this point, if I go back to this code right now, notice I can put final over here if I really wanted to. Or I can put not null if that is something I want to use, or any other annotation. I can put annotations when I'm specifying the type like this. However, if I'm not using the type, if I'm using type inference, I cannot put annotations. This is not a valid syntax. So you cannot use type inference if you want to use annotations. Either you can use annotation with type, or you can use no type and no annotation and just the variable name for type inference. That was a limitation of Java 8. But that was one limitation of Java 8, but unfortunately there are other limitations we need to worry about. So there are times when your type inference will fail because it simply doesn't have enough context on its hand. And that can be really frustrating at times. Why does the code work in one setting? Why not in another setting? I'll just give you a clue about it, and then I will let you kind of figure out, or we can take this conversation afterwards just to see why this could be a problem. But just to kind of give you a little teaser on this one, let's look at one example here. Notice that I'm going to take a create people, and on this one, I'm going to simply say sorted, and then I would say for each, and I'm going to simply say system.out and print line, and I'm going to print it. Now, what am I going to do in the sorted? In the sorted, I'm going to say given a person, well, we'll say comparing, and given a person of type person, of course, I'll say person. And what I want to do here is to simply say person.getName. So when I run the code, you can see that in this case, it is going to do the comparing that's coming from the comparator. So we'll simply say static, and we'll bring in the comparator and bring in all the functions within the comparator at this point. So this is going to be the sorted function, of course, on the stream, and we will ask it to perform the sorting. Now that worked, obviously, but notice that how I use the type information in here. And you might say, gosh, why can't you use type inference? And sure, that's a really good point, and I'm going to use the type inference, and you can see that works. And just to emphasize, the fact that I call this a person doesn't really matter. You can call it whatever you want to call it. Type inference still decides that it's a person. Now, having said this, of course, let's go a little bit further. That code is working, but let's go a little further with this. Now, what I want to do is do the same operation one more time. So let's comment this out. But this time around, what I want to do is take the result of this operation. Again, let's put the type in here for a minute. And then I'm going to say that it is going to be a dot over here, reversed. So I'm going to reverse this operation and put them in the reverse order. So you can see that Bob is in the bottom right now, and Sarah is on the very top. So that is the reversed working, and we can say, yeah, that's great. But once again, you may ask the question, why not use type inference? Well, notice how we were able to use type inference over here. So we can go back over here and remove the person from here, And then when we execute the code, we get a compilation error. In fact, the error says getName is not available on a type of object. Now, when we don't understand why this code doesn't work, we normally say Java is stupid. But if we really understand why this works, we say that I am stupid. So usually I prefer the second one because I can get educated and none of us have to be stupid at that point. Well, the point really is this can be really frustrating. And the reason why this doesn't compile is type inference is based on the context. And if it doesn't know what the context is based on the surrounding, it obviously cannot really infer the type, and it falls flat by knowing the minimum what it can know. In this case, it's object. So something to really ponder about. If you're really interested in this further, we can take it offline. I won't have time to go deeper into this, but just to give you a teaser about it, there you have it. So with that said, Java 9, of course, supports anonymous inner classes with the Dimond operator. I mentioned that. Now let's get down to Java 10. Java 10 has type inference for local variables. So local variables can be inferred in type. So to understand what that means, let's say string greet is equal to hello. And I'm going to output the greet. And of course, in this case, we said what the type of greet is, and we set the value for it, and we printed it. And just to make no mistake, if I were to say .foo, notice what the error says. The error says variable greet of type string. There is no problem at all. We know what the type is. However, if you look at this code, what is the type of greet? Well, obviously, it's a string, but is it because we told it's a string? Well, not really, because we assigned a string to it. So as a result, what you can do is replace the string with the var. And when you run the code, it still works. Now, there are there are three things I want to emphasize right now. The first thing is type inference is all about compile time thing. This has nothing to do with runtime. So at compile time, the compiler determines the type of greet is a string. Second thing, it only does this when all the information is available to it. Third, the type inference does not compromise any performance, any security, anything for you. So that is something you need to keep in mind. It's a matter of convenience to remove the verbosity in code. Now, you may ask me the question, all right, Venkat, is it really such a big deal that you put the word string instead of var? You literally saved 2 characters of typing. Well, okay, I give that to you. It's not a big deal right now. But there are times when you type a type which is type angle bracket, something comma, angle, another type angle bracket, and then you pause and ask the question, did I get enough angle brackets given? And there are days you do that, isn't it? That's when you know var is a good substitute because you don't have to write all of that. And sometimes you may say, oh, come on, Venkat, I never type that. I just write my code and I gently right-click on my IDE. And before I blink, my IDE vomits the type in front of me. Well, guess what? You have to live with that vomit forever. And every time you look at the code, you got to look at that vomit of the type in front of you, and your brain has to parse through it. Why bother seeing it if you don't care about it? Now, just to emphasize this part one quick minute, if I say .foo right here, notice that the error says variable greet of type. And that just to emphasize, it knows at compile time that greet is of type string. I'll take this one more further to emphasize this really quickly, if you don't mind. I'm putting the string back, as you can see right now. I'm going to go to the command prompt really quickly here. I'll go to the directory where my code is sitting. And I'm going to now take a look at the classes directory. I'm going to blow that away for a second and see if this is what I'm actually using. So I'm going to just go ahead and compile and run this really quickly, and it said hello. So, okay, so what I want to do now is I want to say Java P minus C is the option I've aliased on my machine already. So we'll take a look at the bytecode really quickly. And I'm going to go to the classes and sample.classes and take a look at the bytecode really quickly. And when I take a look at the bytecode, what I notice in the bytecode is the following. So right there is the bytecode it created. Now, no confusion over here. What you have is an LDC string hello. I'm going to leave that highlighted for you for a minute. We'll come back to this in just a second. I'm going to go back to this code and change it to a var right now, and you can see it said hello. And just to emphasize it, I put a little exclamation so you know it's different. So I go to the command prompt one more time, and I do the Java P one more time, and this is the second one I brought in. And notice the hello with an exclamation in the very end. Look at the line I've highlighted. It's LDC string hello exclamation, whereas the old one is the string without the exclamation. The bytecode is exactly the same at that point because type inference figures the type at compile time, not at runtime. The bytecode doesn't have anything different in this particular case, and that should be kind of the norm most of the time. If at all there's a difference, it'll be because there was a bit more optimization or inference it was able to make, but nothing is left to the runtime literally. So, but type inference works only when the compiler is 100% sure about the type. Just to emphasize this point one more time, if I were to go back and say string right here, now notice that code worked. Now you know very well that I can write the code like this. I can define the string agreed on the first line. I can come back and set the value later on, and the code actually worked. Now I'm going to change it to a var. Quick show of hands. Will this work or not work? Who thinks it's going to work? A few of us. Who thinks it won't work? All right, more people. And who says I have no clue? Okay, a few of us. And who will not raise your hand no matter what I ask? Okay, there's a few of them. Okay, so that's exactly the point, is that it will not work. Why? Because the compiler says, no way, I'm not going to leave this line of code until you tell me what the type is. Why is this so important? Because it's quite possible you might put an expression in this line of code, and that may vary what the value is, and that can be a little bit confusing. So as a result, it is not going to permit to use it. So in other words, essentially, it has got to know what the type is. It's got to be initialized on that line, and otherwise type inference will not work. So that's pretty safe in a way. It's going to know what the type is before you leave that line of code. There's no confusion about it. Now that's one thing to keep in mind. It's got to be given the type initialized right in there. You can use this for local variables. We saw that. But similarly, what you can do is the following. Suppose I have a string, let's say over here, list of strings, and I say names is equal to list of, and let's say we have some names over here. I can say a string over here, name, coming from names, and I can output the name, as you can see right in there. Alternatively, I can use a var right there as well. And as a result, I can simply loop through and print the values. So a var can be used for a for as well, because after all, that's a local variable within the scope of the for. Similarly, if you are using a try with resources, so if you say resource is equal to new resource, where you have some resource at some point, and then you're going to call some function foo on it, well, you can replace this with a var as well. So you can use a var for a local variable, for a for variable, for a try with resources. Those are some of the places where you can use that really nicely. Now, of course, given this, you cannot use this for a field. So if you were to define a field over here, so private, let's say int max equal to 200, and I'm going to go ahead and say OK. You can see the compiler is OK with it, but I cannot put a var in here. That will not work. You cannot use a var for a field. Now, obvious question is, why not? And my answer is, not yet. So there is no reason why this cannot be done. They're going to wait for the riots to slow down, and then they will introduce this feature, in my opinion. So I don't see a reason why fields cannot really have this kind of approach. Languages like Scala actually do this, and a few other languages do this as well. So there's nothing really that limits it. Now, having said that, and I'm happy for the next one, and I hope that stays the way ever in Java. Parameters are not type inferred. So as a result, for example, if you were to write a function, let's say public void foo, int a, and I'm going to say in this case output a dot, whatever a method, an int method, whatever the method on int may be. Well, you cannot change it to a var no matter what. Now, I'm happy for this. One language that does that, and as much as I respect Haskell, this is one of the things I don't like about Haskell. Haskell can actually infer the type of parameters by examining the body of the function. And that's a little unsettling for me because I want the interface to be a lot more stable than the implementation is. So I'm not a big fan of that particular approach in Haskell. And Scala, even though Scala and Kotlin were inspired by Haskell, they both decided not to provide type inference for parameters. And Java doesn't, and I hope that Java stays that way. I'm almost confident Java will not make that mistake and provide type inference for parameters because that's going to drive me crazy. Okay, so, so having done that, let's talk a little bit about some caveats we have to be very careful about in how we can make use of this. The first and foremost, please don't use type inference with Dimond operator. So here's an example. If you were to say integer, let's say over here, and I'm going to say numbers is equal to, and I'm going to say a new array list, and then I'm going to write the code like this. Then I say numbers.add1. And then I'm going to output the numbers. And similarly, I'm going to say numbers.add2, and I'm going to run the code. And you can see that actually worked. Now, on the other hand, if you had tried to say numbers.add, let's say hello, you know that will not compile. Well, the reason, of course, is you cannot send a string where an integer is expected. That makes really good sense. However, if I were to go back to this code and change this to var, now this, really one-word comment could be bad idea, right? So don't do this. This is terrible. Why? Because at this point, what does the compiler know? Well, if you ask me really, I really wish they had given a compilation error. And if they chose to give a compilation error, the error would have been a very simple one-liner, are you an idiot? And I would have been happy with it. But instead, they let this go through, which kind of bothers me. So when I run this code, unfortunately, it ran. But what is the type of numbers? Well, unfortunately, it can work with only what it knows at this point, which is almost nothing. So as a result, if you were to add a string to it, you can see that it doesn't really reject it. So please don't allow this. Do code reviews. And if you have developers who write this code, give them a warning and say, please don't write this code again. If they continue to write it, well, we'll talk about that elsewhere. Okay, so the point really is that we shouldn't write code like this. But so this is something you got to be careful about. Never use. I'm hoping IDEs and tools will be smart enough to flag this and say, don't do this. So that would be really nice. At least as IDE support would be nice in this area. So don't do this on Dimond operators. And I want to put a disclaimer before I talk about the next one. The problem I'm going to say here is not a problem of var, but the problem is exacerbated because of var. The problem I'm going to show you has been around for at least more than a decade, and we got to be a bit careful about it. I'm sure you're aware of this problem already, but let's take a quick look at it. So let's look at one example here. I'm going to say list of integer, and I'm going to say over here, oh, let's say numbers is equal to new array list. And in this case, what I'm going to do is to provide a list of, let's say, 1, 2, and 3. So I have a list of 3 numbers right now. I'm going to output those 3 numbers really quickly, and it's 1, 2, and 3. Then I say numbers.remove, and I'm going to remove 1 out of it. When I run that code, notice the result is 1 and 3. Now, why is it 1 and 3? Because remove decided to remove the element 1 as opposed to element 0, and so you see a 1 and 3. What I want you to do for me is a favor. Remember the result of this call. It is 1 and 3. So leave that aside for a second. That's 1 and 3. But on the other hand, if I were to change this to a collection of integer, now what happens? The output is no longer 1 and 3. Unfortunately, it is 2 and 3. Now, this was a problem from Java 5 days. Now, what is wrong with this code? The problem with this code is it is violating the Liskov substitution principle. Liskov substitution principle says the derived class should not have a different behavior compared to the base class. So when they overrode and overloaded the remove function, you should never change the signature in the derived class. Now, obvious question you may ask is, if that is so wrong, why did they do it? And I have the most logical explanation: because they were drunk. I mean, otherwise there's no reason to do something like this, in my opinion. So this was a terrible idea. We shouldn't have done this in the first place. Now, having said that, though, imagine you have written a code like this one in the first place, and your output is 2 and 3. And I come along, and being the fan of type inference, I decide to change this to a var. Now, what did I do? I changed the behavior of the code, isn't it? Because a second ago, the code was giving me 2 and 3 as an output. Now it is going to give me 1 and 3 as an output. That's terrible. I hope I have enough automated tests to catch me and give me a slap on my face. Don't do this. So the point really is, you got to be very careful when you are just throwing var into the place. It can be a double-edged sword. If you're not careful, it can hurt us. Be a little careful about it. And I'm not saying this to scare you and say not use it. I'm a big fan of type inference, but I'm just showing this to you to know that be careful. You just don't throw in and walk away. You got to make sure the behavior of the code is not any different, because there are other influences that can come and change what we are looking at. Similarly, if you were type versus base versus derived, for example, what if you had a code where you say base b equal to new derived? And in this case, b dot base method will work, right? This is fine, but you cannot do base dot derived method, as you know, because that's not possible. Now, if you were to suddenly change this to a var, what is the type of b now? It's going to be derived, and as a result, this will be okay as well. And is that what you really wanted? To take this a little further, remember the age-old advice in effective Java. When defining a variable, define a variable of the least privilege. For example, if the right side is a class, the left is an interface is better rather than making it as a class. Well, when you use a var, it's going to use the type on the right side because it only can use what's in the context. Well, keep in mind, this is not such a big deal because it's a local variable, not a return type of a function. But nevertheless, you got to be a bit careful about it. So remember that the type is inferred based on what it knows, not what you think it is in your mind. So that's something to keep in mind. And if what you think is synchronized with what it decides, it's in good shape. The next thing I want to show you here is about lambdas. So I'm a big fan of lambdas, and another thing I'm really big fan of is how Java designed lambdas. Java decided to use functional interfaces to implement lambdas as a way to store the lambda references. But lambdas themselves don't have type. It only gets a type when you associate it with a functional interface. So in this case, I say runnable, and then R is equal to, and I'm going to say output, let's say you called. And then I'm going to come in here and say r.run, and then I'm going to call the run function. So you can see that actually worked. But to emphasize this point, if I had, for example, my interface called foo, and my interface foo has a run method right in there. Now you know that I can actually do the following. I can set that to foo also. They're not just runnable, because it really is based on whether the lambda can fit into the declaration of the method. The method doesn't take anything, it doesn't return anything, so it is, as long as that is a match, you are in good shape. So the point I made right now is that lambdas themselves don't have type. It depends on what you bind it to, a functional interface. Could be foo, it could be runnable, or anything that has a method that doesn't take anything and return anything, this particular lambda can be bound to. Well, having said that, then, when you define runnable over here, and then you say runnable R, now I'm interested in putting a var here. Well, if you put a var, you are telling the compiler, go determine the type of this lambda. Well, it doesn't know the context, and as a result, it's going to give you an error. And the error says lambda expressions need an explicit target type. So you cannot really assign to this with a var. Now, when I say you cannot, what I mean is you should not. Because you know how some developers are. They never take no for an answer. And they will tell you, yeah, you can. And you say, no, you can't. And they will say, I'll show you how. And they'll put runnable over here. Now, this is stupid, right? So, don't. And so, when I say don't, I really mean don't. Because what good this did do, it's worse than what we had before. So, when I say cannot, seriously don't, right? There's no reason to go that route. So, those are some of the caveats to keep in mind. In about 10 minutes we have with us, I want to talk about a few benefits we have and a few other things. So first of all, one of the real reasons I love using type inference is that it reduces clutter. I'm not dealing with the type information in front of me I don't need to look at. And so especially if I have something really complex, like for example, a map angle bracket, a string comma, let's say angle bracket, list angle bracket, person, or maybe even worse, a map of something. And then you put this and say, did I get this enough? And then you go home and your family looks at you and says, what's all this bruise from? Oh, all those angle brackets I had to work all day. Well, you don't have to really deal with it. This kind of almost feels like XML at this point. You don't have to be doing that. You can simply throw that away and put a var. It is easy to evolve the code. To me, programming is a series of mini experiments. I mean, have you ever seen anybody who sits down and says, I'm going to write code, and they type code and everything works and they walk away, right? That never happens. Usually I write some code, I bang on the keyboard, I bang on the wall, I scream, and then eventually something kind of begins to work. Now, to me, that is what programming is. It's a series of mini experiments. And when I'm experimenting with the code, what good is it to perfect the code when you are trying to really experiment with it? So if you tell me, you got to tell me what the type is over there. You got to tell me what the type is here. And I'm like, come on, give me a break. I'm just trying to see if this even makes sense. And then, of course, people, if you don't listen to that, these young programmers start programming in Python after that. Like, why? Well, the reason is it's a language that allows you to experiment. It doesn't tell you every 2 lines, you got to do this, you got to do this, you got to do this. It's like the in-laws are watching over your shoulder every few minutes. Well, it's nice to be able to say var and just say, I don't care about the type right now. Yes, it is there. I have it in my mind, but I don't care to waste my time on it. Once you get a little bit of code working, go back and put all the type you want into it. In fact, you can use your IDE to generate that for you if you want to. So this is a nice way to experiment and evolve the code. It's very easy to reuse the code. Like how? Well, let's take a quick example of how this could be the case. If I take this collection of persons I have with me, let's try something really quickly right now. What I want to do is to say, create people, let's say .stream. And then I'm going to say .sorted. Well, actually collect. And in the collect, what am I going to do? Let's bring in the collectors for a minute. Then I'm going to say grouping by, and I'm going to say given a person, give me the name of the person. So get name, comma mapping, and I'm going to then say person get age, and then comma, let's say to list. And I can get that to work really nicely, and the compiler is happy with me. How do I know? We'll simply put OK over here to see the compiler is happy with it. So the compiler is happy, as you can see. But imagine I am dealing with 2 different collections right now. Just imagine that for me. Let's say this is a collection 1, that's a collection 2 in your mind. Now, if I write the code like this, what did I just do in this code? Oh my gosh, I duplicated this code in 2 places, or maybe 3 places. And if I do this, then after a while, when I come back to make a change to it, I got to make a change in multiple places, and we all know that can become really smelly. Wouldn't it be nice to reuse that little logic of code? Hey, great idea. So how do I reuse it? I'm going to grab this part of code right there. And I'm going to simply say a grouping. Okay, great, I called it grouping. What do I want to call this one? I'll call it grouping also. Awesome. Then I say grouping is equal to that. Now, that's very good, but what is the type I need to put over here? Oh, you know what? It's a collector. I know that. Okay, so collector, but of what? Now, that's going to be a few minutes of trying to figure it out, at least, isn't it? And you say, no, Venkat, I don't need few minutes because I got this beautiful IDE, which is my vomit generator. Well, then every time you look at this code, you got to see it. But what about var? In meaning, I just don't care right now. I just want to reuse it. You know what? You didn't care about it a few minutes ago because it was hidden in a parenthesis. Why do you care now? Now, you may say, but I'm really curious what the type is. Guess what? Take your mouse, hover over that variable, and your IDE, if it is smart enough to vomit, it should be smart enough to show you what the type is. What if you're not using an IDE that shows that to you? Guess what you can do? You can say grouping dot foo. Let's just call that and see what it tells us out of curiosity. And guess what it says? Collector, person, question mark. Even the compiler doesn't care. So why do you care about it? So the point really is you can just put a var and you can move on at that point. So that is basically yet another place where this makes really good sense. It's a lifesaver when it comes to debugging. You're in the middle of debugging and you have this function call and you're like, I'm curious what the type here, what the value here is. So what do? You put that into a temp variable. And then you say run, and the compiler says, do you know what type this is? And you're like, are you serious right now? This damn code doesn't work. And you are asking for a type right now, and the compiler says, you need to know the rules of the language. And you're like, I'm out of here, right? So that is the annoyance. You know what? Just help me out here. That's not important to me right now. Just put a var and move on. Well, two more things I want to quickly show you here. One of them is just a little puzzler. So if you were to say, let's say in this example object, I know that's really nasty. So let's say list is equal to, let's say for example, list of 1 comma, let's say hello. Now I'm going to just put a little try block and I'm going to put a catch block over here because I'm interested in the compiler compiling, not the code executing. Because you may point out saying, aha, but the list is immutable, don't worry about it. So I'm going to go ahead and add a 2 over here. And now when I run this code, the compiler shouldn't really complain. That's what I'm looking for. And you can see the compiler was happy. Don't worry about the runtime at this point. Well, the compiler was happy with this. OK, great. Now what am I going to do? I'm going to go back here and change this to a var. And you know the compiler is happy right now. But what was the type of list before? The type of list before was list of object. The question is, what's the type of list now? Well, before I answer that question, let's go here and say new sample. And there's a little bit of a surprise available to us. You can see that did not work. Now, you may look at this and say, huh? Why doesn't that work? Well, because the compiler does a lot of work for us. And it did an analysis and found out there is something common between 1 and hello. That is called an intersection type, and it determines the type of the list actually is an object, serializable, comparable of that extends from that. So it actually really analyzed the code and found an intersection type for us. And that's what you saw right there. With that said, one more thing I want to show you quickly here, which is really a charming feature. Let's create a little quick example here. Let's say I have a function over here called getPrice, and this is going to take a string, let's say ticker, and return the value back to us for this particular ticker. So this is going to become return, let's say integer, we'll say math.random times 1,000. With that, I wrote the best code that predicts the stock market right there. So now I'm going to say a string, let's say in this case tickers. Let's just simply say we'll create a bunch of them. So list of, let's say, bunch of them. So Goog over here, let's go ahead and say AMZN, and then of course maybe ORCL. So great. Now what I want to do is the following. I can say, for instance, something along these lines. I can say list of integer, we can say prices is equal to tickers.stream, and then I'm going to say over here map. Given at the ticker, what do I want to do? I can say get price for the ticker. Well, great so far. I can say collect, and I can collect it to the list over here. And once I collect to the list, I can then come back here and say output, let's say prices. So for, let's say var price coming from prices, and I'm going to simply display that right here, output price. Well, the collectors, of course, we need. So given this code, of course, you may argue that, hey, this is great, it produces the price, but I want to know what ticker the price belongs to. How do I do that? Here's an idea. Let's create a new tuple, and then this will be a ticker, comma, get prices. Oh, darn it. Just remember, Java doesn't have tuples. So what do we do? Well, let's try something a little different. New object. And I created an object right in there. And what does this object do? This object has a string, a ticker, which is going to be the ticker. It contains an int price, which is going to be get price of the ticker. So let's take that really quickly. Well, the good news and bad news. Good news, that code is awesome. We created an object. Bad news, what is the return type over here? Well, the return type is a list of whatever this type is. But what is that type? Oh, it's an anonymous inner class. You go to the compiler and say, hey, compiler, can you tell me what the type is? I won't. Well, what do we do? Well, here's one place where you can beat the compiler in its own game. You say, compiler, what is the type? I won't tell you. Do you know what the type is? Of course I do. It is that. And the compiler is like, checkmate. Okay? So now what can we do? We can come down here and say, given the price, I want to output, what do I want to output? A price.ticker plus a few dashes plus price.price. Of course, we'll name this better. So that is basically a way for you to get that from the anonymous type as well. So this is a pretty much an edge case, but you're able to pull that information out of it very nicely. So really quickly, a few more things I want to cover and then be done with this. So pardon for the little tardiness here in finishing. So a few quick things. Var is not a keyword. If you really want to mess with somebody at work, just don't tell them I told you this, but go for this. Just say over here, var equal to 7, and have some fun with it. This is amazing code, as you can see, because var is not a keyword. And this is purely contextual, so you can do something like that. Well, a couple of things. Java 11 removed a particular restriction that was there. Remember that annotation of the Lambda expressions parameters. Good news, that restriction is gone in Java 11. So if you want to annotate your parameters, simply put a var with the annotation. So var with annotation, or no var, no annotation, type inference without the var. So you can go that way. So quickly to summarize what we talked about, a few recommendations to take home or to the office. First, don't use it with Dimond operators. Don't put type information in the name. Just to emphasize, sometimes people do this. They say var names list. They cling on to the type. No need for it. Just let go and be free. Don't say the type with the name of the variable. Make sure the type is what you really wanted it to be. Do enough testing. Specify the type unless it's dead obvious. Now, one more thing you may ask is, how do I convince my programmers to use this? I'll tell you how I do this. I start using var in my unit test. My unit tests are usually very small. I start putting var in it. People get comfortable. And one day they ask me, hey, why are we not using that in code? I say, that's a great idea, and move on. And of course, use var for temp and debugging, use for reusing, like I showed in the grouping by, and use var when you want to annotate Lambda expressions. I know that was quick. I hope that was useful. Thank you.